If you were to stand on the desolate, cratered surface of the moon and cast your gaze back across the dark, silent void of space, you would witness a phenomenon that stands in stark defiance of the thermodynamic logic of our solar system. You would see a brilliant sapphire sphere, wrapped in swirling white clouds, gleaming against the endless, indifferent black. It appears peaceful. It appears inviting. It looks like a jewel suspended in the void. But to a cosmologist, this blue marble is not merely beautiful. It is a problem. It is a profound paradox. By all the known laws of physics and planetary formation, that water should not be there. We inhabit a planet that is 70% covered in liquid solvent, yet we orbit a star that acts as a nuclear furnace. We exist in a zone of the solar system where thermal radiation should have boiled every drop of moisture away billions of years ago. The Earth should be a dry, scorched rock, as barren as Mercury or as dusty as Mars. Instead, we are drowning in oceans. This water is the defining feature of our world, the cradle of our biology, and the solvent of our existence. But its origin remains one of the deepest, most contested mysteries in planetary science. To understand why our oceans are such a statistical anomaly, we must first look at the invisible boundary that divides our solar system. Astronomers have mapped a thermal border in space known as the frost line, or the snow line. It operates on the same principle as a campfire in the dead of a cosmic winter. Close to the fire, the thermal energy is too intense for snow to exist. Water can only survive as steam or vapor, but if you walk far enough away into the darkness, you cross a threshold where the temperature drops sufficiently for water to freeze into solid ice. In the early solar system, this line was located roughly somewhere between the orbits of Mars and Jupiter. Everything inside this line, Mercury, Venus, Earth, and Mars, formed in the dry zone. Here, the intense heat of the young sun vaporized any volatile compounds. The dust grains that clumped together to build our planet were rocky and metallic, stripped of their moisture. By the standard model of accretion, the Earth was born from dry rocks in a dry region under a hot star. So, when you look at the Pacific Ocean, you are looking at an alien substance that has somehow found a home where it does not belong. The birth of our planet was not a gentle accumulation of matter. It was a violent, chaotic demolition derby. 4.5 billion years ago, the Earth grew by accretion. Countless asteroids, planetesimals, and rocks smashed into one another, their gravity pulling them together into a growing sphere. Each one of these collisions released a tremendous amount of kinetic energy, which was instantly converted into heat. The young Earth was not just hot, it was molten. In this forge of creation, even if there had been traces of water trapped inside the original rocks, the intense heat of accretion would likely have boiled it away, stripping it into the fierce solar wind of the newborn sun. This era is known as the Hadean Aeon, named after Hades, the Greek underworld, and it is an appropriate title. If you were to look at the Earth 4.5 billion years ago, you would not recognize it. There were no continents, there was no green, there was no sea. The surface was a churning, glowing ocean of molten rock, a global lava field that radiated heat into the dark vacuum. The sky above was likely a hazy, toxic orange, choked with carbon dioxide, nitrogen, and vaporized rock. In this hellish landscape, liquid water was a physical impossibility. Any molecule of H2O that touched the surface would have instantly flashed into steam and been lost to the upper atmosphere. This was the zero point of our planet. Just as the young Earth began to cool, just as it might have started to form a thin, fragile crust, the universe delivered a blow that reset the clock entirely. This is the giant impact hypothesis. It suggests that the Earth was not alone in its orbit. It was stalked by another planetary body, a Mars-sized world that scientists have named Theia. The collision was inevitable. Theia slammed into the proto-Earth with a force that is beyond human comprehension. It was not merely an impact, it was a merger. The violence of this event liquefied the planet completely, blasting trillions of tons of molten rock into orbit, a ring of fire that would eventually coalesce to form our moon. For the story of water, this moment is critical because it was a sterilization event. The heat generated by the impact was so intense that it would have vaporized any volatile atmosphere the Earth had managed to cling to. If there were puddles, if there were early shallow seas or even damp rocks, they were instantly annihilated. The Earth was left spinning. While wobbling and utterly parched, it was a reset button that guaranteed a bone-dry beginning. Following the violence of the Theia impact, a profound silence fell over the inner solar system. The debris cleared, the moon settled into its orbit, and the Earth began the long, slow process of healing. The magma ocean, once churning and white-hot, began to darken as heat radiated out into space. A skin began to form on the surface of the lava. This was the first crust. It was likely a jagged black landscape of basalt and obsidian, brittle and unstable, constantly cracking and sinking back into the molten depths below. Imagine a world of black glass under a faint, distant sun. There was no sound of wind, for there was barely an atmosphere. There was no sound of waves. The only noise was the ticking of cooling rock and the deep, low rumble of the mantle beneath. The vessel was ready, the cup was formed, but it was empty. The planet was a parched desert floating in the dark, waiting for a drink that it could not provide for itself. The water had to come from somewhere else. It had to be delivered. And about 3.9 billion years ago, the delivery service arrived. The solar system was not the stable clockwork mechanism we see today. The giant planets, Jupiter and Saturn, were migrating, shifting their orbits in a gravitational dance that threw the rest of the system into chaos. Their immense gravity acted like a slingshot, disrupting the orbits of millions of asteroids and comets residing in the cold outer reaches beyond the frost line. These icy rocks were hurled inward toward the sun and directly into the path of the Earth. This era is known as the Late Heavy Bombardment. For millions of years, the sky fell. The Earth was hammered by a rain of cosmic debris. These were not small meteors. They were mountain-sized chunks of rock and ice slamming into the black crust with the force of nuclear arsenals. Looking up from the surface, the night sky would have been a terrifying kaleidoscope of streaks and flashes. When scientists first began to look for the source of Earth's water, their eyes turned naturally to the outer solar system and the comets, the dirty snowballs of the cosmos. For decades, it was the leading theory that these comets were the architects of our oceans. But science demands evidence. To prove that comets filled our oceans, we had to taste them. We had to compare the chemical signature of the water on Earth with the water on a comet by measuring the ratio of deuterium, or heavy hydrogen. In 2014, the Rosetta spacecraft analyzed the water on Comet 67P. The results were a shock. The water on the comet was heavy, with a deuterium ratio 3 times higher than the water in our oceans. It was a chemical mismatch. The romantic theory collapsed. The dirty snowballs may have added a sprinkle, but they did not fill the basin. The investigation turned to a drier, rockier source, the asteroids, specifically a class known as carbonaceous chondrites. To the naked eye, these look like ordinary dull gray stones, but appearances in space are deceiving. These rocks are cosmic sponges. Their mineral structure is rich in hydrous clays, minerals that have water molecules locked tightly inside their crystal lattice. They can contain up to 20% water by weight. As they smashed into the Earth during the bombardment, the heat of the impact liberated the water, releasing it as steam. This was not a sudden flood, but a slow, grinding accumulation. Meteor by meteor, pebble by pebble, the oceans were delivered in the form of hydrated dust. This process created a new, dense atmosphere. The planet was essentially sweating its oceans out into the sky. The atmosphere became a crushing dense blanket of water vapor, carbon dioxide, and volcanic gases. The pressure at the surface was immense, perhaps hundreds of times greater than it is now. It was a pressure cooker on a planetary scale. The water was there, billions of tons of it, but it was trapped in the sky, refusing to touch the ground. The planet was locked in a standoff between the cooling vacuum of space and the radiating heat of the molten crust. The cooling was inevitable. Heat radiated away into the dark, and the temperature of the upper atmosphere began to drop. It crossed a critical threshold. The water vapor molecules, which had been vibrating with thermal energy for millions of years, began to slow down. They clumped together. They condensed. High in the stratosphere, the first clouds formed, not the fluffy white clouds of a summer day, but dark, heavy, bruising storm cells that spanned the entire globe. And then it happened. A single drop of water condensed around a speck of volcanic dust. It grew heavy enough to overcome the updrafts of the hot air below. It fell. It fell through kilometers of steam, surviving the heat, and struck the black, jagged surface of the cooling basalt. It likely did not make a splash. The ground was still too hot. The drop would have hit with a violent hiss, flashing instantly back into steam. For centuries, this was the cycle: phantom rain. But the rock was losing its battle. Each drop that hit and evaporated stole a tiny fraction of heat from the ground. Drop by drop, hiss by hiss, the surface cooled, and finally one drop landed and stayed. Once the cycle began, it did not stop. This was the Great Deluge. It was a storm that defies human categorization. Geological models suggest that once the atmosphere destabilized, it rained continuously for perhaps 10,000 years, maybe even 1,000,000. It was a deluge of biblical proportions, but with no one there to witness it. Imagine the sound, the relentless, deafening roar of water hammering against rock, unbroken by silence. Day or night, century after century, lightning would have been constant, tearing through the dark, steam-choked sky, illuminating a landscape that was being washed clean. This was not fresh, gentle rainwater. It was hot, and it was acidic. As the rain fell through the carbon-rich atmosphere, it absorbed carbon dioxide, turning into carbonic acid. It didn't just wash the rocks, it dissolved them. It etched the mountains and scoured the valleys, stripping the crust of its salts and minerals. The water followed the simple law of gravity. It flowed downhill. Rivulets became streams. Streams became raging torrents of gray, hot sludge. And torrents became rivers. They poured into the great basins, the scars of the ancient impacts. At first, they were just puddles, just steaming shallow pools in the bottom of craters. But the rain kept falling. The puddles connected. They deepened. They swallowed the lands. The lava fields were submerged, hissing and cooling into pillow basalts under the rising tide. Slowly, inexorably, the black rock was hidden beneath a rising blanket of gray. The magma ocean was being replaced by a water ocean. And when the clouds finally broke, when the sun finally pierced the thinning veil of the atmosphere, it shone down not on a red planet, but on a new world, a water world, where a single unbroken global ocean covered nearly the entire planet, leaving only a few lonely chains of volcanic islands to puncture the surface of the alien sea. The dry world was gone. The blue marble was born. With the skies finally clear and the deluge ended, the Earth had become a water world. But this primordial ocean was not the welcoming blue expanse we know today. If you could stand on one of the lonely volcanic peaks poking through the waves 3.5 billion years ago, you would be looking out at an alien sea. The water was not blue, it was a murky, heavy olive green. In our modern world, oxygen in the atmosphere reacts with iron to create rust, which settles out of the water. But in the early Earth, there was no free oxygen. The iron remained dissolved, suspended in the liquid, giving the global ocean a metallic, toxic taste and a deep green hue. The sky above was likely not blue either, but a hazy pinkish-orange, colored by high levels of methane and carbon dioxide. It was a landscape of sickly colors, a green ocean under an orange sky, hot, heavy, and utterly hostile to the life that would come later. The water was scalding, perhaps nearly 100 degrees Celsius at the surface, a global bath just below the boiling point. The most striking feature of this early water world was what was missing. There were no continents. The great land masses of Africa, Asia, and the Americas had not yet formed. The granite that makes up the core of our continents is a lighter rock that floats high on the mantle, but the process of creating it, distilling it from the heavier basalt, takes billions of years of tectonic churning. In the Archean Eon, this process was just beginning. The Earth was a true water world. A single, unbroken global ocean covered 95, perhaps 99% of the planet. The only land consisted of chains of black volcanic islands, similar to modern-day Hawaii or Iceland, spewing ash into the wind. Because there were no continents to act as brakes, the ocean currents were ferocious, circling the equator in unimpeded super-fast loops. The tides, pulled by a moon that was much closer to Earth than it is today, were extreme. Tsunami-sized waves scoured the volcanic islands twice a day, dragging debris back into the green depths. It was a world of violent hydrodynamics, a restless churning machine of water and stone. This relentless churning brings us to a chemical mystery. The salt. Rainwater is fresh. The water that fell for 1,000,000 years was distilled, pure steam. So why is the ocean salty? The salt did not come from the sky. It came from the rock. The atmosphere of the early Earth was thick with carbon dioxide and sulfur. When the rain fell through this gas, it became carbonic and sulfuric acid. This acidic rain attacked the volcanic rocks on the islands with chemical ferocity. It broke down the crystal lattice of the stone, leaching out ions, sodium, chloride, calcium, magnesium. These minerals dissolved into the rainwater and flowed in rivers down to the sea. This is the Great Titration. For billions of years, the rivers have been acting as a conveyor belt, stripping the continents of their salt and dumping it into the ocean. Once the salt is in the ocean, it is trapped. The water evaporates to form new rain, but the salt stays behind, concentrating over eons. Every cup of seawater contains the dissolved ghost of a mountain that was washed away long ago. The ocean is not just water, it is a liquid fossil of the land. To find the true purpose of this new global ocean, we must dive. We must leave the storm-tossed, radiation-bathed surface and descend into the crushing blackness of the abyss. Here, along the fracture lines of the ocean floor where the crust is thin and the magma is close, we find a phenomenon that bridges the gap between the geosphere and the biosphere, the hydrothermal vents. In the darkness, they look like chimneys, towering spires of mineral deposit, belching black and white smoke into the water. But this is not smoke. It is superheated fluid, water that has seeped down into the crust, touched the magma, and shot back up, loaded with minerals. This is the meeting point of the planet's two great forces, fire and water. One specific type of vent, known as the Lost City Fields, creates a unique environment. Here, the water is alkaline, warm, and rich in hydrogen gas. It bubbles up through microscopic honeycomb chambers in the rock. These rock chambers act like tiny test tubes. In this warm, mineral-rich darkness protected from the chaotic violence of the surface, the water is doing something extraordinary. It is organizing. It is acting as a medium for complex chemistry, churning the raw elements of the earth until they begin to resemble something ordered. Water is not a passive stage for life. It is the active ingredient. In the Archean oceans, the water acted as the universal solvent. It dissolved the minerals from the vents, caught the carbon-rich dust falling from the asteroid impacts, and absorbed the lightning-charged gases from the atmosphere. It took all these chaotic, disparate ingredients and mixed them together in a global solution. This was the primordial soup. But soup implies a mess. Water does something more than just mix, it structures. Inside the microscopic pores of the hydrothermal vents, the water molecules surrounded the organic compounds, protecting them, allowing them to concentrate. It allowed amino acids, the building blocks of proteins, to link together. It allowed fatty acids to form bubbles, the precursors to cell membranes. It was a process of billions of trials and errors, a chemical lottery played out over eons in the dark. The water provided the safe harbor, the temperature buffer, and the transportation network that allowed these molecules to meet, to interact, and eventually to replicate. The ocean was not just a body of water, it was a planetary womb. Why water? Why is life on Earth not built on liquid methane, ammonia, or silicon? The answer lies in the strange, sticky physics of the water molecule itself. Water is a dipole. It has a positive end and a negative end, like a tiny magnet. This allows it to dissolve almost anything, breaking down nutrients so they can be transported. But more importantly, it allows structure. Consider DNA, the spiral ladder that holds the code of life. DNA is held together by hydrophobic interactions. Parts of the molecule hate water and curl inward, while parts love water and face outward. The shape of DNA, the double helix itself, is sculpted by the water that surrounds it. Without water to push and pull on these molecules, our genetic code would unravel into chaos. Proteins fold into their functional shapes only because of how they interact with water. Life is, in its essence, a complex dance of molecules suspended in H2O. We are not just creatures that drink water. We are creatures made of water, organized by water, and sustained by the unique anomalous physics of this single simple molecule. Water is familiar to us. It is the most common substance in our lives. But to a chemist, water is a freak. By the strict rules of the periodic table, liquid water should not exist on Earth. H2O is a tiny, light molecule. Based on its weight and structure, it should behave like its chemical cousins, ammonia or methane. It should be a gas at room temperature. On a planet like ours, all the water should have boiled away into vapor or frozen into ice ages ago. There should be no liquid middle ground. But water cheats. It survives as a liquid because of a unique property called hydrogen bonding. The water molecules are sticky. The hydrogen atoms of one molecule are magnetically attracted to the oxygen atoms of its neighbors. They cling to each other with a ghostly, transient grip, forming a shifting web that holds the molecules together against the urge to fly apart into gas. This invisible web is what gives water its surface tension, allowing insects to walk on it. And it is what allows water to remain liquid over such a vast range of temperatures. Without this molecular stickiness, the oceans would evaporate, our blood would boil, and the earth would be enveloped in a dry, toxic fog. There is another rule that water breaks, a rule so fundamental that we rarely think about it. In the physical universe, when a substance gets cold, it contracts. Its molecules pack tighter together. It becomes denser and heavier. Solid rock sinks in molten rock. Solid iron sinks in molten iron. But water does the opposite. As it approaches the freezing point, the molecules arrange themselves into a rigid hexagonal crystal structure. To fit into this shape, they have to push apart. Ice is less dense than water. It expands. It floats. This anomaly is the only reason we are here. Imagine if water obeyed the normal laws of physics. Ice would be heavier than water. In winter, the ice forming on the surface of the ocean would sink to the bottom. The dark abyss would fill up with layer after layer of sunken ice, shielded from the sun, never melting. The oceans would freeze from the bottom up, turning into solid blocks of ice that would lock away the planet's water forever. Life would be crushed or frozen out of existence. But because ice floats, it forms a skin on the surface. This skin acts as an insulating blanket, trapping the heat in the water below, or keeping the deep ocean liquid and warm enough for life to survive even the harshest ice ages. We tend to think of the ocean as a permanent fixture, a bathtub that stays filled, but the ocean floor is actually a moving conveyor belt. At the bottom of the deepest trenches like the Mariana, the tectonic plates of the earth are colliding. One plate slides beneath another, plunging down into the hot, viscous mantle. This is the process of subduction, and as the rock goes down, it takes the ocean with it. The water does not pour down a hole like a drain. It is chemically locked into the crust. The rocks of the seafloor are saturated, hydrated by millions of years of pressure. As these massive slabs of stone descend into the fire of the interior, they carry trillions of tons of water with them, dragging the ocean deep underground. Recent seismic studies suggest that at the Mariana Trench alone, 3 times more water is being swallowed by the Earth than we previously calculated. It is a slow, silent leak. The planet is drinking its own oceans, pulling them back into the deep reservoir from which they likely came billions of years ago. But the Earth is a cycle, not a tomb. What goes down must eventually come up. The water dragged down by the subducting plates does not stay buried forever. As the rock heats up in the mantle, the water is squeezed out. It rises, mixing with molten rock to fuel the explosive volcanoes of the Ring of Fire. But sometimes it returns in a stranger form. On the floor of the Pacific, there are mountains that do not spew fire. They spew mud. These are the cold seep mud volcanoes. And towering structures formed by the eruption of crushed rock and deep pressurized water from the subduction zone. They release fluids that have been trapped underground for eons. Water that has cycled through the very heart of the world. This hidden cycle, from rain to ocean to mantle and back to volcano, acts as a long-term regulator. It ensures that while the surface oceans may rise and fall, the planet itself never truly dries out. This deep water does more than just cycle. It performs a function that keeps the Earth alive. Geology tells us that plate tectonics, the shifting of continents, the building of mountains, the recycling of the crust, is unique to Earth in our solar system. Venus is a planet of the same size and composition, yet its surface is a single locked, stagnant lid. It has no tectonic plates. Why? The answer again is water. Water acts as a planetary lubricant in the deep crust and upper mantle. Water molecules soften the rock. They lower the melting point and reduce the friction between the vast plates of stone. Without water, the Earth's crust would be dry, rigid, and seized up. The continents would freeze in place. The recycling of carbon would stop. The volcanoes would die. The planet would become geologically comatose, just like Venus. It is the water slicking the gears of the deep Earth that allows the continents to drift. The very ground we walk on is mobile only because it is floating on a hidden layer of wet rock. The ocean is not just a habitat. It is the engine oil of the planet. To fully appreciate the strange beauty of Earth's open water, we must look at the competition. For a long time, we believed we were the only water world in the solar system. We were wrong. There are other oceans out there, but they are hiding. Orbiting Jupiter is the moon Europa, a ball of fractured white ice. Orbiting Saturn is Enceladus, a tiny glittering snowball. To the eye, they look dead and frozen. But gravity tells a different story. As these moons orbit their massive gas giant parents, they are squeezed and stretched by immense tidal forces. This friction generates heat deep inside their cores. This internal heat melts the ice from the bottom up. Beneath the miles-thick rock-hard shell of ice on Europa, there is a liquid saltwater ocean that may be 60 miles deep. It contains more water than all of Earth's oceans combined. But it is a stealth ocean. It exists in eternal darkness, cut off from the sun, the stars, and the atmosphere. It is a sea trapped in a planetary pressure cooker, warm and mineral-rich, but forever sealed away by a roof of ice. This comparison reveals the true anomaly of Earth. In the universe, it seems that the default state for liquid water is to be hidden, to be buried beneath a protective crust of rock or ice. Underground oceans might be common, but a surface ocean, a naked ocean like ours, is rare. Our water lies open to the sky. It interacts with the wind to create waves. It evaporates to create rain. It reflects the light of the sun. This openness makes our planet vulnerable. Without the protection of a thick ice shell, our oceans rely entirely on the delicate balance of the atmosphere and the magnetic field to keep them from boiling away into space or freezing solid. We are walking a tightrope. The beauty of the Pacific or the Atlantic lies in their exposure. They are the lungs of the planet, exchanging gases with the air, driving the climate, and creating the chaotic sunlit environments where complex life could evolve eyes to see the stars. The hidden oceans of Europa may have life, but it is life that will never know the concept of a horizon. The story of water does not end with the geology of the planet. It continues inside you. When life finally crawled out of the ocean onto dry land hundreds of millions of years ago, it faced a crisis. It was leaving the womb. On land, the air is dry and the sun is harsh. To survive, life had to take the ocean with it. It had to internalize the environment it was leaving behind. You are a vessel for this ancient sea. The human body is roughly 60% water, but it is not fresh water. Your blood plasma, your sweat, and your tears are salty. The concentration of salt in your fluids is remarkably similar to the salinity of the primordial oceans where life first began. We never truly left the water. We simply built spacesuits of skin and bone to carry it around with us. Every time your heart beats, it is pumping a chemically modified version of the Archean Sea through your veins. We are walking, breathing aquariums, keeping the memory of the deep past alive in our own physiology. If you zoom in further, past the organs and the tissues, down to the microscopic level of the single cell, you find the same truth. The interior of a cell, the cytoplasm, is a watery gel. It is a microscopic ocean. The machinery of life, the DNA, the proteins, the mitochondria, does not function in a vacuum or in a solid. It floats. These molecules are suspended in water, pushed and pulled by the same thermal currents and chemical properties that govern the tides. The folding of a protein, the precise shape that allows it to do its job, is dictated by how it interacts with water molecules. The transmission of a nerve signal is a flow of ions through a watery channel. In the most literal sense, life is just a complex, organized dance of water. Without the solvent, the dance stops. The dry land we stand on is an illusion. At the cellular level, we are all still swimming. Consider for a moment the water in the glass beside your bed. It looks simple. It looks clear. But every drop has a history that spans the entire age of the solar system. That water was forged in the death throes of a star, frozen in the deep cold of the outer solar nebula, and carried to Earth inside a rocky asteroid during the Great Bombardment. It has cycled through the planet for 4.5 billion years. It has been steam in the Hadean atmosphere. It has been part of a glacier that crushed a continent. It has been swallowed by a dinosaur and transpired by a giant fern. It has been dragged down into the mantle and spewed back out by a volcano. The water you drink is not new. It is recycled, purified by the great planetary distillation of evaporation and rain. You are drinking the same molecules that rain down on the cooling crust of the infant Earth. The water is the only witness to the entire story. But this story will not last forever. The Earth is a closed system, but it is not perfectly sealed. High in the upper atmosphere where the air is thin, ultraviolet radiation from the sun breaks water molecules apart. The oxygen stays, but the hydrogen, being light, can escape the pull of gravity. It drifts away into space. This is atmospheric escape. It is a slow, invisible leak. Every second, Earth loses a tiny fraction of its water to the void. Over billions of years, this process will dry the planet out. As the sun ages and grows brighter, the heat will accelerate this loss. The oceans will eventually boil, the atmosphere will be stripped away, and Earth will become a parched, dead rock, much like Mars or Venus. The blue marble is a temporary state, a wet phase in the long, dry life of a planet. We are living in the golden age of water. For now, the cycle holds. The sun heats the ocean, the water rises as vapor, the clouds form, and the rain falls. It is the heartbeat of the biosphere. Listen to the sound of rain against the window. It is a sound that has been heard on this planet for 4 billion years. It is the sound of the atmosphere cooling the rock. It is the sound of the ocean returning to the land. We are drawn to this sound. We find the noise of waves crashing on the shore or the steady drum of a rainstorm deeply, instinctively soothing. Perhaps this is because, in a very real sense, it is the sound of home. We are creatures of the water, exiles from the ocean living on dry land, carrying our own internal sea within us. The sound of water reconnects us to our origins, to the time when we were just simple cells floating in the warm chemical broth of the early earth. We have spent this time talking about the water, but we have not spoken about what the water is hiding. There is a mystery that lies not in the fluid, but underneath it. Our search for the lost lands begins in the vast, seemingly empty expanse of the South Pacific. If you look at a standard map, you see Australia and, thousands of miles to the east, the islands of New Zealand. Between them lies nothing but blue water. It looks like a void, a blank space on the map of the world. But if you were to strip away that water, if you could pull the plug on the Pacific Ocean, you would see something that defies geography books. New Zealand is not an island chain. It is merely the highest mountain peak of a sunken giant. Beneath the waves lies a sprawling landmass nearly 2/3 the size of Australia. It has mountains, it has valleys, it has plateaus. It is a distinct, continuous piece of continental crust that broke away from the supercontinent Gondwana 80 million years ago. Scientists call it Zealandia, or in the indigenous Maori language, Te Reo Maui. It is the Earth's 8th continent. Unlike the others, Zealandia could not keep its head above water. Its story is a geological tragedy. As it drifted away from Australia and Antarctica, the crust was stretched. It behaved like hot taffy being pulled apart. It became thinner and thinner. And as it thinned, it lost its buoyancy. It became heavy. The underlying mantle could no longer support it. 23 million years ago, the ocean rushed in. The valleys flooded first, then the plains, and finally the hills. 94% of the continent was drowned, disappearing into the blue silence. We must try to imagine the world that was lost. Before it sank, Zealandia was a lush green raft. It was covered in ancient Araucaria forests, giant ferns, and unique biological experiments. Because it broke away from Gondwana before the rise of mammals, it became a sanctuary for birds and reptiles. It was a land where dinosaurs might have lingered longer, where the tuatara, a reptile that is the last survivor of a lineage older than the dinosaurs, still walks today on the few peaks that remain above water. When we sail across the Tasman Sea, we are floating over a lost world. We are moving over fossilized forests and ancient riverbeds that have not felt the sun for 20 million years. It is a ghost continent, a sleeping giant that lies just beneath our keel, waiting in the dark. While Zealandia was lost to geological time, other lands were lost to human time. To find one of the most poignant of these drowned worlds, we must travel to the cold, gray waters of the North Sea. Today, this is a rough, inhospitable stretch of ocean separating Great Britain from mainland Europe. But just 8,000 years ago, this sea did not exist. Instead, there was a paradise. This was Doggerland. It was not merely a land bridge. It was a vast, lush subcontinent, the true heart of Europe. Imagine a continuous rolling landscape of tundra, wetlands, and rich grasslands connecting the limestone cliffs of England to the coasts of Denmark and the Netherlands. The Thames did not flow into the sea. It was a tributary joining the Rhine to form a massive European superriver. Great herds of woolly mammoths, reindeer, and wild horses roamed here. It was perhaps the richest hunting ground in the entire northern hemisphere. We know this because the sea sometimes gives back what it stole. Fishermen dragging nets across the bottom of the North Sea have pulled up the black fossilized tusks of mammoths, the skulls of woolly rhinos, and, most chillingly, the tools of men. harpoons carved from antler, stone axes, and the delicate bones of humans who lived, loved, and died on a land that is now a seabed. The end of Doggerland was a slow-motion apocalypse that lasted for millennia as sea levels rose, turning plains into salt marshes. But the final blow was sudden. Around 6,200 BC, a massive underwater landslide off the coast of Norway, known as the Storegga Slide, triggered a mega tsunami. A wall of water 20 meters high raced across the North Sea, slamming into the marshy remnants of Doggerland. It devastated the coastline, drowning the remaining islands and sweeping away human settlements in a single afternoon. When the water receded, the land was poisoned, broken, and largely gone. Britain was severed from Europe. The heartland was erased. The story of the drowned worlds is a prophecy of our own future. We view the map of the world as a static painting, drawing borders and building coastal cities as if the land is permanent. But geology teaches us that the coastline is a transient, moving boundary. We are currently living in an interglacial period, a brief warm pause between the ice. But the ice is melting again. The cycle of marine transgression, the invasion of the sea, is beginning once more. If we look at the map of the modern Earth with the eyes of a geologist, we are looking at the future lost continents, the low-lying peninsula of Florida, the vast river deltas of Bangladesh, the coral atolls of the Pacific. These are temporary features. As the oceans expand, these lands will follow the fate of Doggerland. Our cities of glass and steel will become the underwater ruins of the future, colonized by coral and kelp. The ocean is patient. It has claimed continents before, and it will claim them again. As we reach the end of this journey, the pieces of the puzzle merge into a single, breathtaking image. We have looked at the water that regulates the temperature, the magnetic shield that protects the air, the deep biosphere that permeates the crust, and the cycles of destruction and rebirth that recycle the surface. When you step back and look at these systems working in concert, the Earth stops looking like a rock. It starts looking like an organism. This is the Gaia hypothesis. It suggests that the Earth is a self-regulating complex system that maintains the conditions necessary for life. Much like a living body maintains its own temperature and chemistry, the volcanoes are the vents, the ocean is the blood, the atmosphere is the lung, the magnetic field is the skin, and we, perhaps, are the neurons, the first part of this vast planetary body that has opened its eyes and awakened to consciousness. We are the way the Earth knows itself. We came here asking where the water came from. We found that it is a cosmic traveler, a survivor of the Hadean fire, and a sculptor of continents. But in tracing the water, we found ourselves. The atoms in your body were once part of the asteroid that brought the sea. The salt in your blood is the memory of the first ocean. The electrical rhythm of your brain is the echo of the lightning in the sky. We are not passengers on this ship. We are the ship. We are the temporary shapes that the water and the rock take so that they can walk and breathe and wonder. The history of the Earth is not something that happened in the past. It is happening right now in you. You are the current chapter of the story. You are the memory of the planet made flesh. And now the journey is done. The cycle is complete. The water has fallen from the sky, carved the land, and returned to the deep. The lost continents sleep in the dark. The hidden bacteria wait in the stone, and the planet hums its low, steady lullaby. You can let go now. You are part of this vast, resilient, and beautiful system. The Earth has held you since the moment you were born, and it will hold you through the night. The silence you hear is not empty. It is full of life, full of history, full of stars. Let the rhythm of the planet carry you. Let the deep time wash over you. Good night.